When you're finishing up your book from Book Creator, you need to be able to calculate the slope between your two cities that you found. When we calculate slope based on coordinates, we have a little bit of difference than we do when we're doing it on a graph. I'm going to show you 3 different examples about how to do so. Definitely skip ahead if the examples don't apply to your type of city and to your coordinates. But definitely move around as you need to. You don't need to watch the entire video, but make sure that you get the hang of how to do it. As I'm starting to do and define my slope between my coordinates, I'm looking at a graph, and this graph that I have example has everything labeled. And so I have all my longitudes labeled and I have all my latitudes labeled, which makes it really nice and easy. It's exactly like reading a graph. You don't have that luxury. So I'm going to show you exactly how, using those same ideas, you can still calculate your slope using these specific examples. So this example goes from point A to point B. Now, I don't have specific names of the cities or anything along those lines, but we can still say I'm trying to get from North America to South America, and I want to know my slope. So first I need to calculate my rise and my run from point A to point B. First, I'm going to find my coordinates from my point. At A, I have an x value of, it looks like it splits between 120 and 90, and that would put me at 105 degrees west of the prime meridian. And that gives me a latitude of 45 degrees north of the prime meridian. So really, I have an x value and a y value. Now I look to point B. And point B tells me that my longitude, first of all, which is along my x-axis, that I am at about 75 degrees west and 15 degrees south. So first I need to calculate my rise and my run in order to get from A to B. I look at my rise, and rise is change of y. So I'm looking at how my latitudes change. So from A to going down to B, I go down there, and it looks like I traveled 45 degrees to get to the equator, and then 15 degrees further south in order to get to my latitude point. That gives me a total travel distance from A to B at negative 60 degrees. Negative because we went down. Now as we start to transition, okay, I'm looking for my run. From this point here, how far do I need to run in order to get to B? Well, if I'm at 105 degrees and I'm running to 75 degrees, I change by about 30 degrees to the positive direction. So I moved 30 degrees this way. So now my rise is negative 60 and my run is 30. I can reduce that down, negative 60 over 30, to equal negative 2 over 1. Therefore, my slope when connecting line A to line B is negative 2. Every time my latitude goes down 2 degrees, my longitude goes up by 1 degree. Every time my latitude goes down 2 degrees, longitude goes up by 1 degree. As we look at exploring from B to C, it looks like I have a bigger gap, so I'm going to do some different calculations. Let's look at my B coordinates one more time as I trace B up to my longitude. It looks like I am at 60 degrees west. And my longitude tells me I'm at 15 degrees south. And when I look at C, I can see that I am at, tracking it to in between 120 and 90. That gives me 105 degrees east of the prime meridian. And C is 45 degrees north of the equator. So let's start to take a look again, rise over run. So if I'm looking at my rise, I'm looking to see from B, how can I get up to C? And it looks like I need to travel 15 degrees to the equator, and then another 45 degrees to get up to C's level. So it looks like I've traveled now 60 degrees in total. So 15 plus 45 gives me a total distance of 60 degrees. So I'm looking at my Y change. I'm going from 15 to 45 above the equator, which gives me a total distance traveled of 60 degrees. Now looking for my run to get from B to C. And I start at 60 degrees west of the prime meridian, and it looks like I traveled to 105 degrees east of the prime meridian. So it looks like if I travel 60 degrees to get to the prime meridian, that would be 60 degrees, plus another 105, that is 165 total degrees. Both of them are positive because I went up and to the right, both in positive directions. So now when I connect B to C, I can say the actual slope is 60 over 165, and when I reduce, I can divide both by 15 to equal 4 over 11, giving my total slope of every time I increase latitude by 4 degrees, I increase longitude by 11 degrees. As we move over to our D to C example, again, got to map my coordinates. So D gives me a coordinate of, let's see, my x value, if I trace it all the way down, is 30 degrees east. And look at my longitude, look at my latitude, and I'm 15 degrees north. And then from C, if I'm going to C again, C was, let's see, my longitude tells me I am at 105 degrees east and 45 degrees north. So I'm looking now for my total change from my Y and from my X. So if I'm going from 15 to 45, that means I need to rise by positive 30. So I went up, and that was my rise, that was my vertical change. I need to run by, I went from 30 to 105, which is an increase of 75. And then if I do my division, I can divide both by 5, and I get left over with 6 over, let's see, 75 divided by 5 equals 15. So I'm left with 6/15, and again, I can still reduce, so I can divide both by 3, and I'm left with 2/5. So for every time I increase 2 degrees in latitude, I go to the right 5 degrees in longitude. Again, both positive because we're going up and we're going to the right. So when I draw my actual line to connect D to C, I know that my slope can be represented as M equals 2/5. And now I found my slope using those ordered pairs. Skip around, use these different examples, and use these to help you create your book. And best of luck finding your slope between your two ordered pairs.